that we did on Tuesday of week 5. And we were starting to talk about resistors. So we had a combination of resistors. We had 2 resistors in series. Let's call this the 3 kilo ohm and the 6 kilo ohm resistors. And they were connected in parallel with a 3rd resistor. This was 2 kilo ohms. So we'll call this maybe 1, 2, 3. And so what we wanted to know is find the equivalent resistor. And what we had found is that if things are in series, that means that they must have the same current. So different voltages. So number 1 and 2 are in series, but they have different voltage. So what does that mean? Well, what that means is that the voltage across the combination is equal to the voltage across 1 plus the voltage across 2. And we know that V equals IR, so it's the current they have in common, R1, plus the current they have in common, R2, which means this is the same thing as R1 plus R2 times I. And so the net voltage is equal to this thing times the current that they have in common. Now, to be fair, a lot of people, once we've derived this once, just remember that the combination of 2 resistors in series is the same thing as R1 plus R2. And so that means we can redraw our circuit as a 9 kilo ohm resistor, 3 plus 6, in parallel with a 2 kilo ohm resistor. Now these 2 resistors are in parallel, and we said that in order for them to be in parallel, you could do a loop rule, say starting in the parking lot and going up one ski route and down the other, and then up one and down the other, and so on and so on and so on. But the idea is that when you get back to the parking lot here, you have to have a net change in the voltage as 0. So what that means is that they have the same voltage. One would be positive and the other's negative if you're going in a circle, which means they have different current. But what I do know is that the combination, the net current, if you will, is equal to the current through one plus the current through the other. And we actually also could have gotten this by applying Kirchhoff's junction rule at this junction. But anyway, we'll use V equals IR again. So we have V over R plus V over R. And that means that they have, if I pull out the common voltage that they have 1 over R1 plus 1 over R2. And once we've done this once, we usually remember that this thing must be, therefore, 1 over R net. Okay, so I'll do that now. 1 over R net is 1 over 9 kilo ohms plus 1 over 2 kilo ohms, which is, let's see, 18, so 2 18ths. There we go. Plus, this one's 9, 18 kilo ohms, which is, let's see, 11 over 18 kilo ohms. So that means that R net is equal to 18 over 11 kilo ohms. And when we pull out our calculator and we figured out what 18 over 11 is, the important thing, I think, to remember here, this was 1.63 kilo ohms, that this is actually less than either 2 kilo ohms or 9 kilo ohms. So when you add them in series, you're actually reducing you're actually reducing the net resistance. And so the answer is that we have one resistor across these points here, these points A and B, that is the equivalent resistance of 18/11 kilo ohms. And that's the end.